Hello friends, welcome again. Today we are going to start our chapter Relations. In the last video we have learned about the Cartesian product of sets. Now today we will start the topic Relations. This topic is very useful as from this topic so many questions comes in 11th, 12th and IIT. And as I told you earlier, in 11 CBSE, you don't have this chapter, but in 11 CBSE we have only first part of this chapter, whereas in 12 CBSE we have the second part of this chapter, whereas in 11th RBSE this chapter is completely in syllabus. So let's start the topic relations. Relation is always defined between two sets A and B. Means a relation can be defined only if we have two sets. So mathematically we can say that a relation is always defined between two sets A and B such that each and every relation is a subset of A cross B, which I have written over here. A relation is always defined between two sets A and B, and any subset of the set A cross B will be called a relation from A to B. इस बात को हमको समझने की जरूरत है कि रिलेशन डिफाइन होने के लिए दो सेट्स का होना जरूरी है. रिलेशन हमेशा दो सेट के बीच में होगा, सेट A और सेट B. इसका मतलब A क्रॉस B, द प्रोडक्ट ऑफ टू सेट. कोई भी रिलेशन A क्रॉस B का सबसेट ही होगा, ये हमको समझना पड़ेगा. So what is mathematically a relation is a subset of A cross B, and whereas ordered where A comma B belongs to R, then we say that A is related to B by the relation R. Means if A comma B belongs to R, this implies A related to B. इसको समझने के लिए you can take a very simple example. A is a set of teachers, B is set of students. In set of teachers there are 3 teachers P, Q, R, and in set of students there are 4 students A, B, C, D. Now what is the relation? That element of A is teacher of element of B. So we will see that P is teacher of A, P is teacher of B, P is teacher of C, Q is teacher of A, Q is teacher of B, and so on. And we can write it in ordered pairs, that P comma A, P comma B, P comma C. This is usual example which we use in our daily life. We will take furthermore example to understand what is a relation. Now the next thing comes the domain and range of a relation. So it's very simple when we write a relation in ordered pairs. जब हम एक relation को ordered pairs में लिख देते हैं, तो जो उसके first elements हैं, the first elements of all ordered pairs are known as elements of domain. उसके सारे first elements domain के element होंगे, and all the second elements are known as elements of range. सारे second element range के element होंगे. This is called domain and range. Mathematically, if A related to B, then domain is all A such that A comma B belongs to R. मतलब सारे first element क्या कहलाएंगे? Domain कहलाएंगे. And range B such that A comma B belongs to R means second सारे element range कहलाएंगे. अब एक फार्मूला और पढ़ते हैं, उसके बाद हम एक एग्जांपल लेंगे इसको समझने के लिए. एक फार्मूला मैं आपको बताना चाह रहा हूं, that is total number of relations. किन्हीं भी दो सेट में how many relations can be made? Total number of relations between two sets. दो सेट के बीच में कितने रिलेशन बन सकते हैं? तो याद रखिए, if order of a set A is M and order of set B is N, then total number of relations defined from set A to set B are 2 power Mn. Out of these 2 power Mn relation, one empty relation is also there which is known as phi. So if we say how many non-empty relations, कितने non-empty relation होंगे, तो वो होंगे 2 power Mn minus 1. This is a very important formula. It is used in so many questions. तो मैं फिर repeat करूं, अगर किसी सेट A में m एलिमेंट है और सेट B में n एलिमेंट है तो A से B में टोटल रिलेशन जो डिफाइंड होंगे वो होंगे 2 पावर mn और टोटल नॉन एम्प्टी रिलेशन जो डिफाइंड होंगे वो होंगे 2 पावर mn माइनस 1, बिकॉज हम जानते हैं किसी भी सेट में एक जो एलिमेंट होता है वो नल सेट होता है, 5 होता है, तो उसको हमने माइनस कर दिया। नाउ वी टेक एन एग्जांपल टू अंडरस्टैंड हाउ वी कैन राइट अ रिलेशन, हाउ वी कैन राइट डोमेन, हाउ वी कैन राइट रेंज ऑन द सेट A of natural numbers here given 1 to 10. A relation R is defined in such a way A related to B. This implies A is equal to 2B. The relation इस तरह से defined है कि A जो है वो twice of B है, where A and B both belongs to capital A. We have to write the relation R in ordered pairs, and we also have to write its domain and range. So here the two elements A comma B belongs to A, and A is 1 to 10. Now the relation is what? A related to B such that A is equals to 2B. Means if we take B equals to 1, then we get A equals to 2. B equals to 2, A equals to 4. So we get 2, 1, 4, 2. Similarly, B is 3, A is 6, B is 4, A is 8, B is 5, A is 10. Now if we take B equal to 6, we get 12. That 12 is not in our set A. Therefore, we cannot write it in our relation. So the relation will have only 5 ordered pairs: 2, 1, 4, 2, 6, 3, 8, 4, 10, 5. Now if we want to write the domain of this relation, the domain will be what? The first elements 2, 4, 6, 8, 10. Range will be second element 1, 2, 3, 4, 5. In general, in the question of relation, nobody will ask you codomain, but if anybody asks you codomain, then codomain will be what? Set A. Because this relation is defined from set A to set A. So the end set where the relation is defined is known as the set of codomain. So here the codomain is A. So I think by this example it is very clear to all of you that how we can write relation. Now we will learn about inverse relation. Then we will take examples to understand this. Now what is the inverse relation? Let A and B be two sets and R is a relation defined between A and B. Then R inverse is a relation that will be defined from B to A such that R inverse is B comma A given that A comma B belongs to R. अपनी लैंग्वेज में अगर आप इसको समझना चाहो तो बड़ा आसान है। R एक रिलेशन है एक सेट A से सेट B पे, तो R इनवर्स क्या होगा? R inverse क्या होगा? R inverse will be opposite of that. That will be from B to A. R set में ordered pairs लिखे हुए हैं written in the form of A comma B. Then in R inverse, the elements will be written in the form of B comma A, which I have written over here. That if R inverse is B comma A, this implies or such that A comma B belongs to R. Clearly, if A comma B belongs to R, this implies B comma A belongs to R inverse. And from this, we can get very easily that domain of R inverse will be range of R, and range of R inverse will be domain of R. Naturally, because the things are inverse. For example, A is a set containing two elements 1, 2. B is a set containing two elements A comma B. Then R is a relation such that 1 comma A, 1 comma B, 2 comma A, 2 comma B. Then R inverse will be naturally the opposite order, that will be A1, B1, A2, B2. Here if you see the domain of R, that is 1 comma 2, this is also a range of R inverse. And if you see range of R, that is AB, that is equals to domain of R inverse. So inverse relation is nothing, कुछ नहीं है ये, जो हमारा R relation है उसका ठीक उल्टा है. इसको लोकल लैंग्वेज में आप अगर समझें, ठीक उल्टा relation, opposite relation. Now I will take another example to understand this relation in a very easy manner. R, if question is what, if R is a relation such that A comma B where a square plus b square is always less than equal to 4. Here a and b belongs to z integers or I. Question is what? Write R as ordered pairs. Also write R inverse and their domain and range. हमको R लिखना है, R inverse लिखना है, उसका domain और उसका range, ये सब कुछ लिखना है. Now हमको relation क्या दिया हुआ है? A and B are related such that A square plus B square is less than equals to 4. मतलब मुझे A भी इंटीजर लेना है, B भी इंटीजर लेना है और इस तरह से चूज करना है कि उसका सम हमेशा 4 या 4 से कम हो. चलिए स्टार्ट करते हैं 0 से. If I take A is equal to 0, then what will I get? If A is 0 means B square is 4. B square is 4 means B can be plus minus 2. So 0, 2, 0, minus 2. Now if we take A equals to 1, then we get B square is less than equal to 3. Means B is less than equal to plus minus root 3. And plus minus root 3 is not an integer. So we cannot take that. Now let's take 2. Similarly we cannot take minus 1. Because minus 1's square is also plus 1. The same thing will happen. Now let's take 2. If we take A is equals to 2, it means B square will be less than equal to 0. So B will be only 0 because square quantity cannot be less than 0. So if we take A equals to plus 2, B equal to 0. And if we take A equals to minus 2, then B is again 0. So the ordered pairs are only 0, 2, 0, minus 2, 2, 0, minus 2, 0. Now if we want to write R inverse, we just have to reverse the order of all ordered pairs. 0, 2, 2, 0, 0, minus 2, minus 2, 0, 2, 0, 0, 2, minus 2, 0, 0, minus 2. Now if we see the domain of R, first element 0, 2 and minus 2. And range of R inverse is same 0, 2, minus 2. Range of R 0, 2, minus 2. Domain of R 0, 2, minus 2. So this is how we can solve the example on relations. I think it is very clear to all of you.